Hello and welcome to another one of these ADD videos. Today we're going to be looking at reduction potentials. So a little vocabulary to refresh our minds if we don't remember what potential terminology is from physics. Potential is the ability to push electrons through an external circuit. Sometimes it's referred to as the electron motive force, or EMF for short. The SI unit for potential is going to be a volt, and the volt is equal to 1 unit of energy per coulomb, or 1 joule per coulomb. Cell potential is the maximum potential a cell can generate, and a standard cell potential is going to be a potential used to compare potentials for different cells. For this to be possible, we need all the concentrations to be 1 molar for your electrolytic solutions at 25 degrees Celsius and 1 atm of pressure. Okay, so basically what we're going to have to do is calculate reduction potentials for all of these, and the reduction potential is the tendency to acquire the electrons so that you can undergo reduction. So if I were to connect a circuit, which one of these would spontaneously undergo reduction, and which one of those would undergo oxidation? Well, in order for us to do that, we have to use a standard electrode, and hydrogen arbitrarily was chosen to have exactly 0 volts. And based off of that, and the fact that our standard electron potential has this formula right here, it's the cathode minus the anode, or in other words, the reduced species minus the oxidized species. Well, what we need to do is we need to have a reference. That hydrogen was a reference. This is the chemical equation for it, and they arbitrarily set that equal to have a 0 volts. Why is this important? Well, we use other metals in conjunction with this reference electrode, the hydrogen, and measure the charge on the electrode. Why do we need to measure the charge on the electrode? Well, that'll tell us which one's the anode and which one's the cathode, which one's undergoing the oxidation, anode, which one's undergoing reduction, cathode. Okay, and then once we measure with a voltmeter, we can create a reduction table. Okay, so this voltmeter will tell us the volts. And why is that feasible? Well, if I know, oops, sorry about that. Let me reduce my size here. So it'll be basically like this. If it's E of cathode minus E of anode for the standard reduction potential, and if hydrogen is going to be positive, that means the hydrogen would be the cathode, and it would be 0 minus whatever number you got here, and you get a negative reduction potential. Whereas if it's the other way around, if the hydrogen was positive, if the hydrogen electrode is negative and the other metal is positive, then the hydrogen, or the anode, is going to be the 0, and we would get a reduction potential greater than 0. Okay, and the voltmeter would tell you specifically what this number here would be. Okay, so you would need to reference a standard reduction table. You can find that in any chemistry book or any Google or Bing or whatever you use as your search engine, and you can determine which ones are more positive. Why would that be important? Well, when comparing two standard reduction potentials, if we have one greater than the other, which we always will, right? They never equal each other. The one that's greater undergoes reduction, and the electrons are on the left side, whereas the one that's less undergoes oxidation. Okay. If the reduction potential is greater than 0, it always undergoes a spontaneous redox reaction, and if it's less than 0, then the reverse is spontaneous. Okay. So basically, once you connect the circuit, you end up with the one with the larger reduction potential undergoing reduction, In our example of copper and silver that we did in the galvanic cell, we end up with the silver being the reduced species and the copper being the oxidized species. Okay? So you might be asked, given two metals, can you, or two elements, can you determine which one's undergoing reduction, which one's undergoing oxidation, and then can you come up with a chemical equation for the two? So make sure you check out the example video, go back through these definitions and make sure you know the SI units and how the concept of a standard reference electrode for the hydrogen was chosen and how it allows us to come up with the reduction table. Most importantly, practice, practice, practice. Thank you and have a nice day.